Hi, Stuart here with another exciting adventure in 12-factor. Today, number 7, port binding. As always, you can find the full 12-factor manifesto at 12factor.net. And here's their formal definition, and we're going to dig into it a little bit. Good application systems are composable. In other words, they're made out of many components, and a component can be a service itself, or a backing service, or both. And so we need a way to connect those in a way that fits with the entire 12-factor pattern. In other words, we need to be able to leverage configuration, and disposability, of course, is a desirable thing, and processes and all those other things. And this all ties together quite lovely. The real thing that made, more than anything, 12-factor possible as a mechanic is IP networking. IP networking was an absolute game changer. And it's worth noting, although the Internet Protocol and the protocols that are built on top of it as part of the 7-layer networking abstraction have changed. For example, HTTP 3 is coming our way, which is a protocol built on top of the IP protocol with some things in the middle. It's quite old and something that has survived the test of time with minimal changes, that is sort of infinitely pluggable to do new things, is quite clever. And the key concept in internet protocol is a from address and a to address, but then this idea of a port, which is just a number on the message that says, when the destination gets this thing, it can decide who should handle it by looking at the port number and seeing if there are any subscribers, so to speak, to it. And if there are subscribers, it's actually possible to have a pipeline pattern. So this one looks at it first and decides if it wants it or not, and so on and so forth. It's also incredibly easy to switch and route, which means that you can do it very efficiently, which means that each node in your network that you have to pass through doesn't really necessarily add a ton of latency. And of course, technology improvements have driven down the latency of switching and routing and other networking things considerably. But the fundamental protocol itself has evolved without a whole bunch of changes. And so the protocol itself enables you to have networking that is incredibly resilient. So here we have an app host running two processes, and process A needs to talk to process B. So there's a couple of ways to do this. If you were in a shell like Bash, you could use a pipe between them. If you were running a couple of services that were running in your operating system service host, you might have a network provided pipe mechanism, essentially a kind of a virtual file. You might want to do perhaps something in memory, and those are all really lovely, and they have trade-offs, and they are excellent for being very efficient sometimes, or they can be terribly inefficient. It's all about how you implement it, but they kind of miss a bet in terms of flexibility. So suppose we reorganize process A and process B so that, in fact, they use IP networking to talk to each other. And so now process A can still call process B. Process A and process B are on the same application host. They typically don't have to go to the network, all capital letters, right? That the host networking is typically set up so that if it recognizes that the origin and destination place are the same, that they don't have to leave that host boundary, and process A can now talk to process B, and that's splendid. And it may be a little faster or a little slower depending on the host networking stack and what you're sending across the wire and so forth, but you can do this. You can move process B to a different application host, and process A and process B can still talk to each other. And what that's really great for is scalability, resiliency, etc. And because we're using port binding and the IP protocol stack, so for example, we could have them talk to each other on HTTP2 across TCP over IP, for example, and we have affordances like IP addresses and DNS addresses and machine names and so forth that are resolvable all the way down to the IP protocol level. Then we have the option of running things on the same host or different hosts, but because Where process B is in configuration, not hardwired into process A. Process A and process B can now be in any place that we want them to be. And as long as they have configuration on startup that tells them how to find each other, then we have a splendid situation. And that's really the art of why port binding is important to 12-factor. Thank you for your kind attention.